problem 5, it says the customer flows a grocery store can be viewed as a Poisson process. Suppose the probability that in 2 minutes at least one customer arrives equals to 0.3. And the first question let us to find what is the lambda. So the probability in 2 minutes at least one customer arrives can be seen as 1 minus the probability that in 2 minutes no customers arrives, which is equals to 0.3. Thus, the number of customer arrives in 0 to 2 is equal to 0. Should be the 0.7, and put the 0.7 into that, it can be calculated that the lambda is 0.178. And the question 2 asks us to find the probability that in 3 minutes no customers comes. The probability in 3 minutes no customer arrives can be simply use the column to find that. Use the lambda which we calculated in problem 1, and use e times minus 3 times 0.178, which the answer is 0.586. And the third question asks us to find the probability that in 10 minutes at least 2 customers will arrive. In this question, the probability in 10 minutes at least 2 customers arrive is equal to 1 minus the probability that in 10 minutes at most 1 arrives. So it is 1 minus the probability the number of customers arrives in between 0 to 10 is equals to 0 or 1. Thus, the answer should be 0.531. And the problem 4 asks us to find the probability that in 1 minute exactly 1 customer will arrive. In problem 4, the probability in 1 minute exactly 1 customer arrives should be equal to the probability that the number of customer arrives in between 0 to 1 equals to 1, and which the answer should be 0.149. In this question, we can see that we can simply solve the question if the problem told us what is the process it is, we can firstly calculate the number of lambda, and in question 2, 3, and 4 we can simply use the formula with the lambda we calculated in first question and calculated the answer finally.